Welcome back to your course on the inflammatory process. We are now in lesson 4. So, what we've been talking about in lessons 1 through 3 are first, it was a general overview. We got into learning a little bit about the blood vessels. But then in lessons 2 and 3, what we focused on is all of our specialized cells that are activated and all the chemical mediators that are released in order to work with those specialized cells. We have a lot of buildup and debris and excess cells and a lot of chemical mediators that all are released into this injured area. And the question now comes to, how are we going to clean all of this up? So, how are we going to take all of this debris, get rid of it, all of our neutrophils and macrophages that might have died in the process of cleaning everything up? We also have a lot of rebuilding that is starting to happen, and there's byproducts that are all released because of this and excess chemical mediators. We are going to clean this up with the lymphatic system. So we're going to take a look at a video that's pulled from another resource through osmosis. If you guys have not experienced osmosis, I do want to put a plug in for them. I do not receive any profits. I have no affiliation with them whatsoever, but their videos on YouTube are absolutely amazing when it comes to physiology and anything in the medical field. So we're going to take a look at the lymphatic system and just pull out a portion of what I want us to pay attention to as we are dealing with the inflammatory response.
Lymph means clear water in Latin, and it describes the fluid that flows through the lymphatic vessels and lymph nodes, which make up the lymphatic system. The three major roles of the lymphatic system, the reason we need it in the first place, are that it returns fluid from the tissues back to the heart, it helps large molecules like hormones and lipids enter the blood, and it helps with immune surveillance to keep infections from running amok. So let's take a closer look at lymph and where it comes from. The blood in the arteries is under a lot of pressure because it needs to reach every little nook and cranny of the body. Those arteries branch out into narrower and narrower arteries, and then arterioles until finally it gets to the capillaries, which have walls that are only 1 cell thick and are slightly porous. Red blood cells are too big to fit through the capillary pores, but small proteins like albumin and fluid can make it through. Every day, 20 liters of fluid, water, and protein seep out of the capillaries and becomes part of the interstitial fluid between the cells. About 17 liters gets quickly reabsorbed back into the capillaries, but that leaves around 3 liters of fluid behind in the tissues each day. This 3 liters of fluid needs to find a way back into the blood so that the body's interstitial fluid volume and blood volume both stay constant over time. That's where the lymphatic vessels, or just lymphatics, come into play. They collect excess interstitial fluid and return it to the blood. Once the interstitial fluid is in the lymphatic vessels, it's called lymph. You might be wondering how there can be 20 liters of fluid seeping out each day if the blood volume is only 5 liters. Well, remember that the 5 liters is constantly in motion, and that it gets recycled over and over every single day. Unlike the circulatory system, the lymphatic system isn't a closed loop, because fluid and proteins make their way into the microscopic lymphatic capillaries, and all of the collected lymph is dumped into the veins. Lymphatic capillaries are the smallest lymphatic vessels, and they're located throughout the interstitial space. Lymphatic capillaries are extremely permeable because their walls are made of endothelial cells that only loosely overlap, forming one-way mini-valves. These endothelial cells are anchored to structures in the interstitial space by collagen filaments, which allows the lymphatic capillaries to stay flexible but retain their overall shape. When the pressure in the interstitial space is greater than the pressure in the lymphatic capillary, the endothelial mini-valves open up, allowing fluid to get in. When the pressure in the interstitial space is less than the pressure in the lymphatic capillary, the endothelial mini-valves are pushed shut, which keeps the lymph inside. Once that lymph is inside the lymphatic capillaries, it travels through bigger and thicker walled vessels, then trunks, and then ducts. There's no pump pushing lymph through the lymphatic system. Instead, smooth muscle in the lymph vessels reacts to the pulsing of nearby arteries by squeezing to get things started. And then the squeezing of skeletal muscles, which normally contract throughout the day, exert external pressure to keep the lymph flowing along, eventually reaching a nearby lymphatic trunk. To keep the lymph from sliding backwards, the lymphatic vessels have valves just like the veins do. Lymphoid organs remove foreign material from the lymph to keep it from entering the bloodstream, and act as lookout points for the body's immune defenses. Some lymphoid organs are in the form of diffuse lymphoid tissue, where they're just a loose arrangement of lymphoid cells and protein, typically in the lining of the gastrointestinal and respiratory tract. Another type of lymphoid organs are lymph nodes, which are tightly packed balls of lymphoid cells and protein. Hundreds of lymph nodes cluster along the lymph vessels, each one a few millimeters to about 1 to 2 centimeters in size. When they're concentrated along the lymph trunks, you can feel them, especially in the neck, armpit, and groin. They can also be found in the intestinal wall, where they're called Peyer's patches. Another lymphoid organ is the spleen, which is about the size of a fist and sits on the left side of the body below the diaphragm and on top of the stomach. The spleen has both white pulp and red pulp. The white pulp is where antibody-coated bacteria are filtered out of the circulation and antibodies are generated by B cells. In a sense, the white pulp of the spleen is like a giant lymph node. Although unlike a lymph node which receives unfiltered lymphatic fluid, the spleen receives blood. The red pulp of the spleen is where old and defected blood cells are destroyed, and their parts, which are the hemoglobin, the heme chain, and the iron, are either broken down or recycled. The spleen is also helpful in that it keeps red blood cells and platelets available in case they're suddenly needed by the body. Really, it's an organ that's got your back in an emergency. A final set of lymphoid organs worth mentioning are the tonsils, which include the adenoid, tubal tonsils, palatine tonsils, and lingual tonsils. Together they form a ring of lymphoid tissue around the throat, and their main job is to trap pathogens from the food you eat and the air you inhale. Alright, as a quick recap, the lymphatic system refers to the one-way network of lymphatic vessels that allows lymph, which is a clear fluid that's squeezed out of the blood, to transport nutrients to cells and act as a method of waste removal. Lymph is cleansed at lymph nodes throughout the lymphatic system, which play an important role in immune function.
Excellent. So, what we've been doing over the course of our lessons is we have started out with the general introduction to thing. We've talked about all of the specialized cells and the chemical mediators that are involved. We've now talked about how everything is cleaned up as well. And what I want to do is take a moment for you guys to pause and to reflect and to summarize for yourselves what has been going on. So, I encourage you right now to sketch out what you know about the inflammatory response. This could be in the form of actually drawing out what's happening under the skin. If you're not much for drawing, it could also be a concept map, which is more like boxes and what is initiating what, and then having the arrows go between these boxes that are all interconnected. So you might be asking yourself, what exactly should be included in this summary that you're creating? Well, let's go back to our cast of characters and events that we've been looking at over the past lessons. So, in lesson one, we had our general introduction and we talked about the blood vessels, right? In lesson two, we talked about our specialized cells. So, that includes like our natural killer cells, our mast cells, macrophages, endothelial cells. And from our cast of characters that we already looked at, I also added in here neutrophils and monocytes to this list. There's also some events that we talked about during that process in our lesson two, which was the margination and diapedesis. So I think that should be incorporated in this summary as well. In lesson three, we talked about the chemical mediators that are involved. And so we do want to reflect what each of these chemical mediators are contributing to. So our bradykinin, our histamine, our heparin, nitric oxide, prostaglandins, TNF alpha, the interferons and interleukins. And then taking a look in lesson four, we had our lymphatic system that we were introduced to. And so, what we want to do now is incorporate everything into a summary throughout this sketch. And this will conclude our lesson 4 of the inflammatory process. We still have 2 lessons left in which we'll come back and we'll talk about treatments for inflammation. And we'll also take a look in lesson 6 at some recovery processes that happen and how we can get our clients returned back to the activities they've been doing.